So, good morning, ladies and gentlemen, or maybe, yeah, there are some ladies here. Thank you again for inviting me indeed. My name is Sadil, and I'll tell you a story about how we deal with batteries at the Czech Technical University in Prague, Faculty of Transportation Sciences, and why we actually deal with them. So in the meantime, when you can read the abbreviations, I just will say something about why do we actually have the Faculty of Transportation Sciences, because when you make a new track, a new road, you probably find better specialists at the Faculty of Civil Engineering. When you make a new vehicle, you find them at the Faculty of Mechanical Engineering. Where you make a new propulsion, you find them in this Faculty of Electrical Engineering and so on. So why actually our faculty? Well, there are two reasons. The first one is that we deal with transportation as a system. So from the system point of view, there are, let's say, more experts at our faculty and more specialists at the other faculties. Second, there are still some topics, even special topics that are actually not covered by the other faculties, and which from the system point of view are somehow a bottleneck of the system as a whole. And the second point was actually our case, why we started to deal with batteries. So this is a history, and maybe it's also a story which I'll tell you a bit about now. Everything has started 15 years ago with the idea of experimental university railway of one of our students. He was very clever, had many ideas, and this idea was about new approaches to the railway, to the local railway, and there were many ideas, and one of them was that there is a lack of light rail vehicle which would have some innovative propulsion. And so the student came to us, and he asked for some cooperation, and we started to find out if such a new vehicle with innovative drive, innovative propulsion of some serial hybrid drive with CNG engine would be feasible or not. And we made many computations and so on, but we quite soon identified the bottleneck of the whole vehicle, which was the battery, of course. And well, we identified some suitable battery for such a vehicle, but we found out that the specification of the battery is not very broad. It covers some specific conditions, so we didn't know what would happen with cycle life if the current will be higher. What would happen if there are some deeper cycles and some shallower cycles. We didn't know exactly what temperature will affect the cycle life, and all these factors for cycle life led us to uncertainty about the feasibility of the whole vehicle. Let's say from the economical point of view. So it was quite a broad introduction, I'm sorry, but this was the story. So we started to deal with batteries like that. And we started from zero. We didn't have anything. So we started with buying some 2 devices, one power source, one load. We put them on the table. We bought some accumulators, some cells, just to become familiar with them. And we started with some cycles, just let's say manually. And as the time flew, we finally came to some automatic cycling of accumulators. And then as we gained some experience, we joined the research group here at the Faculty of Mechanical Engineering, and starting research activities there. So what is a little bit sad or bad is that the experimental railway and this idea of this student never came true. But what is good that we started these research activities, and we made them until now. Just for our defense, we are at the faculty altogether 4 people to this topic, and we made it or make it like at 20% of our work time. So it's not really much effort, but still I think that we made quite a progress in the 15 years. So we started with automated testing of batteries. We started with modeling, first with ECM models. Then we made some. Oh, sorry. Okay, it works. Then we make some progress about the system of sorry again. So we made the models of traction battery. We then bought the battery electric vehicle in daily use, and we equipped it with a monitoring system to gain data from operation. Then we made some progress with the automation of the measurements. So we just have a software pack which has to implement different measuring methods. Then we tried to start with EIS, electrochemical impedance spectroscopy. Further, we started with P2D models, and the last year we were active in a comparison of different driving profiles with constant current discharging and cycle life connected with this. And we have some ideas also for the future. So now I'll go through all the activities. So what do we test? We can measure the characteristics of batteries both in short term and long term, so the performance characteristics and lifetime characteristics. Well, for different chemistries, even for supercaps, we can impose different time waveforms of the current, We are limited with our devices up to 300 amps with a maximum voltage of 20 volts. The basic temperature range is minus 12 to plus 50 degrees centigrade. Other testing method in frequency domain is EIS, which we didn't actually buy the professional expensive devices. We just make one printed circuit board with actually current source controlled by voltage, and we just put the multifunction data acquisition card, some analog output as an input to this control source, and we imposed the AC current to the DC voltage of the battery, and we obtained some voltage response, of course. So that is also why the parameters of EIS are not so, let's say, special good, but it works somehow. Here you can see some typical results. This is the overview how the workplace or our lab or test stand, as you wish to call it, how it looks like. There is the cooled incubator and the power source and load, and just the PC with a multifunction data acquisition card, and with the software which I've written all in LabVIEW, and which implements these different methods. In the last year, we made an innovation. We bought a new source and load in one device. It's called regenerative power system. It has a bit better parameters in terms of current. It can make up to 400 amps. But what is even more important, that it has very precise regulation. So the results are more accurate. It has recuperation back to the grid, and it's a seamless operation source or load, and it has also arbitrary generator which can make any voltage or current profile imposed to the battery. So this is my work for this year. I have to, or not the only one, but the starting one. I have to implement or rebuild the functions for the device, for the old devices to the new device. This is just a show of how the graphical user interface can look like for testing. So there is, of course, some measured voltage, measured current, measured temperature. This is the waveform of the driving cycle WLTP, which we made some experiments in the last 1 or 2 years. So this was about testing, and now a bit about modeling. I think the most of you were present in the last days here in battery course, so I'm not going to repeat all the stuff of my colleagues. But in this presentation, it's always the kind of model introduced, and then what we are doing in that field. So ECM models, we heard many informations about them, so I'll skip the introduction and I'll show some results which we have measured. So first picture is actually internal resistance in time, as we spoke, as Daniel introduced this topic. So this is an example of the cells from Nissan Leaf, and its internal resistance in times from 1 to 15 seconds after the current step. Yeah.
We have just 5 minutes to end.
Okay, no problem. So, or I think we have some 8 minutes in my watch, but okay.
5 minutes and then.
Okay, the discussion. Okay. So, other picture. It's internal resistances and capacitances, but coming from EIS. Some comparison of measured and computed data. Then we came also to P2D model. P2D models. We didn't implement ourselves all the equations, but we used the commercial software GT AutoLion. And as it was spoken about, we had such struggling with parameterization of these models, as we don't have the specialized measuring devices for the electrochemical parameters. So we just used the, let's say, cookbook of the inventor of the software, which was suited for our purpose of common measurements, and try to calibrate these models, but the results were well, sometimes not so bad, let's say here in this case, but sometimes, especially at the temperature point of view, the results were not really nice. Well, we also were able to use the calibrated model of the battery to the vehicle model and find out what the state of charge of the whole vehicle battery is. The next picture related to P2D models is related to comparison of VLTC discharging with constant current discharging at different temperatures. I'll skip 3D models as we don't deal with them yet. Other activity at our faculty is the modeling of battery electric vehicles. As we started with this topic, we had to implement also our own model just to be familiar with the topic. Other activities I spoke about is the electric vehicle itself, which my colleague has in daily use, and it has a new battery. Actually, it is Citroën Saxo, which previously had nickel cadmium. Now it's rebatterized with LFP technology, and well, it serves us for it has been in operation for 10 years and still it's quite okay. Here there are some results from the monitoring of the operation of the battery electric vehicle of the Citroën Saxo. And coming to the end of my limited time, I just can say that we have some ideas what to do. Next, we will still be active in validation of battery models, in model calibrations of different chemistries, different kind of models, comparing them, different operation conditions and so on. what is new, let's say, new topic with coming with a new person to us, with Juraj Maya, which was also present here in the days before, but now had to leave. Is an application of finding out SOH behavior before the battery is going to operation, just to save some money to the bus operator, let's say, typical municipality transportation companies. Okay, thank you for attention. If you have any questions, please ask.
Thank you for your presentation. So you showed that first you worked with electric circuit models, and then actually you are moving towards electrochemical pseudo 2D models.
Yeah, that was the timeline.
Yeah. So could you tell us actually what is your motivation driver for it? Like, is it your internal department, like research, or is it like companies coming in and demanding them, like how this landscape looks like?
Okay, the motivations were two. First, it's more complex model which can somehow compare the chemistries in between. Second, it was we were somehow asked to switch to this model from the boss.
Okay, thank you.
Of the project. Okay. Other questions, please?
Okay, thank you again.